We need to find out the value of the given trigonometric expression. And there's a condition given here that the sum of the two angles A and B, that's 5 pi over 4. Let us begin. So here, we'll start from our given expression. So here we are given cotangent of angle A divided by 1 plus cotangent of angle A, whole multiplied to cotangent of angle B divided by 1 plus cotangent of angle B. Fine. Now we know that the cotangent function, that's the reciprocal of the tangent function. That means cotangent of theta can be also expressed as 1 over tangent of theta. Let's use this. So cotangent of A can be also expressed as 1 over tangent of angle A divided by 1 plus cotangent of A. So we'll replace the cotangent of A with 1 over tangent of A. Similarly, we will rewrite cotangent of B as 1 over tangent of B divided by 1 plus 1 over tangent of B. Now we'll further simplify. So take this particular expression, we're going to multiply both numerator and the denominator with tangent of A. So that becomes 1 over 1 plus tangent of A. So you can check out the calculation yourself. And similarly, we're going to multiply both numerator and the denominator of the second expression with tangent of B. So we get 1 over 1 plus tangent of B. Fine. So we're going to label this as number 1. So our goal will be to find out this value. So before doing that, what we'll do, let's try to only find out the product of the denominator. That's 1 plus tangent of A multiplied to 1 plus tangent of B. Fine, let's use this. So this will be equals to, so we'll have 1 plus tangent of A times tangent of B plus tangent of A plus tangent of B after multiplication. Now what we'll do, we'll try to work with this last two terms, tangent of A plus tangent of B. Here we're going to use the fact that we know that whenever we have tangent of the compound angle A plus B, so that's equals to tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B. Since we need tangent of A plus tangent of B, so we can use this particular equation to rewrite it to get tangent of A plus tangent of B, and that will be simply equals to tangent of A plus B whole multiplied to 1 minus tangent of A times tangent of B. Now we are given here that the value of A plus B, that's 5 pi over 4. So let's try to figure out the value. So we have here 5 pi over 4, and this value is in radians. So let's try to convert it to degrees. All we have to do is replace the value of pi with 180 degrees. So when you solve for this, we're going to get a value 225 degrees. So that means if we take the angle A plus B, which was given as 5 pi over 4 radian, we have converted it to degrees, and that becomes 225 degrees. But here we can rewrite 225 degrees as the sum of 180 degree and 45 degree. Now if we take the tangent on both sides, then tangent of angle A plus B, that must be equals to tangent of 180 plus 45 degrees, but we are going to rewrite 180 as 2 times 90 degree plus 45 degree. The reason why we're writing in this particular fashion, because there is a case here. That means whenever we have tangent of 2 times 90 degree added to an angle theta, then this becomes equals to tangent. Now the reason it's becoming tangent, because we have here is an even multiple of 90 degree. Whenever it's an even multiple, so the tangent function is going to remain as tangent function, but the new angle will now become theta. Now we'll also have to take care of the quadrant of the sign of this function, because that is going to be entirely depend on which quadrant the angle 225 lies. So there's also another benefit of writing as a multiple of 90 degree. So in the first quadrant we have 1 times 90 degree. In the second quadrant we have 2 times 90 degree, which might lead us to think that we are in the second quadrant, but then again we're also adding another angle theta to it. So here theta, this is not an angle equals to 0, it's greater than 0 degree, but since it is less than 45 degree, we'll have to add a small angle 45 degree to the second quadrant, which will take us to the third quadrant. Now we are in the third quadrant. This is where angle 225 degree lies. Now we know that if we use the mnemonics A, S, T, C, So that means in the third quadrant we have a t. So t means the tangent function or the cotangent function. So those two trig functions are positive, everything else is negative. And luckily we are working with the tangent function, so our answer is going to be positive. So we have positive tangent theta, meaning so we're going to get tangent of angle A plus B. So that must be equals to positive tangent of 45 degrees. And what's the value of tangent 45 degrees? So that's 1. So we have obtained that the value of tangent A plus B comes out to be equals to 1. Now we can replace this value here. So we can say that tangent of A plus B, so let me write it here. So we have tangent of A plus tangent of angle B, so that must be equals to, so we have tangent of A plus B, so that's 1. So we have 1 multiplied to 1 minus tangent of A times tangent of angle B. Fine. So we have obtained the value of tangent of A plus tangent of B. So now we're going to come to this particular expression. So we have, let's rewrite everything. So now we have 1 plus tangent of A multiplied to tangent of B, plus we had tangent of A plus tangent of B. So this can be expressed as 1 plus tangent of A times tangent of angle B. Now in place of tangent of A plus B, we can have 1 minus tangent of A times tangent of angle B. So the second term and the fourth term cancels out, the additive inverse of each other. So we are left with 1 plus 1, which is 2. Now we were working with equation number 1. So here finally we are getting the value that cotangent of A whole divided by 1 plus cotangent of A multiplied to cotangent of angle B divided by 1 plus cotangent of B. So this came out to be equals to 1 over, after simplifying, the product between 1 plus tangent of A and 1 plus tangent of B. And we have just now found out the value of this particular product, so that came out to be 2. So that means our final result is going to be 1/2.